Hello dear students, this is our next derivation number 15, equivalent capacitance for parallel combination of capacitors. Okay, this is fairly easy. So this is a basic setup. We have three capacitors which are connected in parallel like this. Okay, and they are connected across a battery which has a potential difference capital V. The capacitance of the individual are shown C1, C2 and C3. The charges would be different Q1, Q2, Q3, but the potential difference, since they are connected across in parallel, so all capacitors will have a potential difference of V, because if this is V, this is V, this is V, this is V, right? So let's start. Q1 would be what? Q1 would be C1 into V. Q is equal to CV is the formula. Q is equal to CB. So for Q1 it will be C1 into V. Similarly Q2 would be C2 into V. Q2 will be equal to C2 into V, and Q3 will be equal to C3 into V. So total charge which will come out from the battery, if that is Q, if this charge is Q, right? So Q should be equal to Q1 plus Q2 plus Q3, sum of all this, right? What is Q? Q, let's say if these three capacitors are removed by a single capacitor, which has a capacitance C effective. So that C effective into V, Q is equal to CV, that is the total charge. So C effective into V will be equal to C1 into V plus C2 into V plus C3 into V. V will be cancelled out, so we'll get C effective is equal to C1 plus C2 plus C3. Though we have derived this for three capacitors, but this can be easily extended. You can imagine, right? There's one more capacitor, this will be plus C4. So this is derived for 3, but it can be extended for n capacitors like this. That is equivalent capacitance or effective capacitance for parallel combination. Thank you very much. Hello dear students, our next derivation number 16, equivalent capacitors for series combination, right? So here we have three capacitors connected in series like this. C1, C2, C3 is the individual capacitance. Now they are connected in series with a battery of EMF V, capital V. Okay, so the key difference here is, or the key concept here is, if there's a Q charge, let's say it is coming out of this battery, right? So this Q charge has to go here, the same charge has to go here, and the same charge has to go here, right? Because it's a series combination, so charge cannot change, right? Like, because we have learned in resistors, right? When they are connected in series, current is same. Current is what? Charge flowing per unit time. So if in series, the charge has to be same. Now in this case, but potential difference will not be same. Across this capacitor it is V1, across this it is V2, across this it is V3, right? So this is the setup. Now if you want to write the value of V1 would be equal to Q by C1, Q is equal to CV, so V is equal to Q by C. So Q by C1, ऐसे V2 क्या हो गया, Q by C2, and V3 क्या हो गया, Q by C3. Very simple. Now if you are moving from this point to this point, right, the total potential drop has to be V, and this is V1 plus V2 plus V3, right? So that means V should be equal to V1 plus V2 plus V3. What is the value of V? If you remove these three capacitors and replace it with a single capacitor of, let's say, capacitance C effective, so that has to be Q by C effective. That is a potential difference across this, Q by C effective, and that has to be equal to Q by C1, Q by C2 plus Q by C3. Q gets cancelled, you get 1 by C effective is equal to 1 by C1 plus 1 by C2 plus 1 by C3. This is a formula for equivalent or effective capacitance for series combination. Thank you very much.